Hello everyone. In today's video, we have a numerical problem where we are going to calculate the density and mass of the air in a room. Now this room has a height of 5 meters, width of 6 meter and depth of 4 meter. The air inside the room is at pressure 100 kilopascal and temperature 25 degrees Celsius. So let's write down the given data. So volume of the room is equal to 4 meters multiplied by 5 meters multiplied by 6 meters, and that is equal to 120 meter cube. Volume of the room is also equal to the volume of the air inside the room. Pressure of the air is equal to 100 kilopascal and temperature of the air is equal to 25 degree Celsius. There are two things that we are interested in: density of the air inside this room, and second, mass of the air inside this room. So now let's see how we can calculate density of the air. So density is equal to mass per unit volume. Unit of density is kg per meter cube. So now in this equation there are two unknowns. Density itself is unknown and mass of the air is also unknown. So there are two unknowns. We cannot calculate density from this equation. Second thing, the air is considered as an ideal gas, and I can use ideal gas equation to calculate the density. So what is the ideal gas equation? PV is equal to mRT, where P is the pressure of air, V is the volume of the air, M is the mass of the air, R is the gas constant of the air, and T is the temperature of the air. I can divide this volume on right hand side. I can write P is equal to M divided by V multiplied by RT. Now this M divided by V is nothing but density. So this M divided by V is density. So P is equal to rho RT. And from this I can write rho is equal to P divided by RT. So we can use this equation to calculate the density, because in this equation we have a pressure of the air which is known to us. Gas constant of the air is already known to us, which is 0.287 kilojoule per kg Kelvin. Temperature of the air is also already known to us. So from this we can easily calculate density. So from ideal gas equation we have derived that density is equal to P divided by RT. So now let's say if we want density in kg per meter cube, what units we should use for pressure, gas constant and temperature. So pressure of the air is given in kilopascal. 1 pascal is equal to Newton meter square. So this kilopascal becomes kilonewton meter square. Gas constant, the unit of gas constant is kilojoule per kg Kelvin. Temperature of the air, instead of degree Celsius I will use Kelvin, because in gas constant you have Kelvin. So that's why I'm going to use Kelvin for temperature. So rho is equal to P divided by RT. So here P is nothing but kilonewton meter square divided by R. R is in kilojoule per kg Kelvin multiplied by temperature, that is in Kelvin. Let's simplify this one. So we have kilonewton meter square multiplied by kg Kelvin divided by kilojoule divided by multiplied by 1 divided by Kelvin. This Kelvin will get cancelled. So what is 1 kilojoule? 1 kilojoule is nothing but kilonewton meter. So I can write here kilonewton meter square multiplied by kg divided by kilojoule. 1 kilojoule is nothing but 1 kilonewton meter. So I will write here 1 kilonewton multiplied by meters. From here, this kilonewton and this kilonewton will get cancelled. I will get kg divided by this meter square multiply this meter, that is equal to meter cube. So unit of density that we are getting is kg per meter cube. So for that we will have to use pressure of the air in kilopascal, or gas constant in kilojoule per kg Kelvin, and temperature in Kelvin instead of degree Celsius. Okay, so now let's calculate the density of the air, which is equal to P divided by RT. So the pressure we are going to use in kilopascal, so 100 kilopascal. Gas constant is equal to 0.287 kilojoule per kg Kelvin. 0.287 kilojoule per kg Kelvin multiplied by the temperature of the air. It should be in Kelvin. So 25 degrees Celsius, we add 273, it becomes 298 Kelvin. So this is 298 Kelvin. So from this, density of the air is equal to 1.17 kg per meter cube. So the next question is, what is the mass of the air inside the room? Mass of the air. So as we discussed previously, density is equal to mass per unit volume. And from this I can write mass is equal to density multiplied by volume. What is the density of the air? It is equal to 1.17 multiplied by the volume of the air is 120 meter cube. So 120 meter cube, and that is equal to 140 kg. So the mass of air inside the room is equal to 140 kg. So we have calculated the density of the air as well as the mass of the air inside the room.